let's say out of this huge population of 100 population, I can have maybe three. If I want to draw, if I say that let me collect out of this population, let me draw out the samples, with each sample consisting of 2 students, then we can have a combinations, like we can do different combinations. And let's say I right now on the top of my head I don't remember permutation combination, but let's say out of the population of those 100 students, I can draw a sample of 300 samples, each consisting of 2 students. So, and then I compute the mean of each sample, and then I find out the standard deviation of those means. Let's discuss this example, and it will become hopefully it will become more clear to you. If it won't, then I will scan those tables and then I'll discuss those with you in the next class, so that this concept becomes clearer to you. My scanner wasn't working today, so I wasn't able to do that. Let's say that out of a group we have a population of ages, and these ages are 10, 20, 30, 40, and 50. A group of people, which is our population, that has ages between 10, 20, 30, 40, and 50. Let's call it a population. Now I want to know, are these 5 data points to know the average age of the group of people? Is it enough or not? Right? So it's my population. Now out of this population of 5 people, I can draw out the sample of 2 in different combinations. So let's say 10, I select here 1, 2, 3, 4, and 5. So I draw out there are different ages, and then I drew out different samples out of it, of 2 people of different ages. So one sample is each sample consisting of 2 people. So 10, 10, 10, 20 is a combination of 10, 10, 10, 20, 10, 30, 10, 40, 10, 50. Then a combination of 20, 10, 20, 20, 20, 30, 20, 40, and 20, 50. Okay, so we drew out different samples out of these population. That gives me 25 possible sample pairs. Okay, which is this, where this whole population is the population of the 5 people whose age I know, and out of that 5 population, using different combinations, I have 25 small samples, each consisting of 2 numbers. Are we clear to this point? Till this point, are we clear? This is the population of 5 people of the 5 different ages. Out of that population, I selected in different combinations small samples, each consisting of 2 data points or 2 ages. Clear? Yes? No? Okay. So these are our small samples. These are our 25 samples that we drew out of that population. Then we find out the sample mean. So this is one sample. Let me put it within parentheses. So this is one sample. This is second sample, which we drew out of that population. This is third sample. For each sample, I find out a mean. So mean of this sample is 10, mean of this sample is 15, mean of this sample is 20, mean of this sample is 25, right? So I computed the mean of these small samples, which is 10, 15, 20, 25, 30, so on and so forth. So I will have how many means would I have now? How many mean points would we have now? Answer this question to me so that I know that you are understanding this. Anyone? How many mean values would I have now? Good. Yes. So I have these 25 means. Now the standard deviation of these means is the standard error. Okay? these are the means, these are the 25 points, these are the 25 means of the samples which we drew out of the population. Population mean itself is 30, right? So 10 plus 20 plus 30, 40 and 50, the population mean is 30. No, not 25 mean errors, just one mean error. That one mean error, no, not 25. See, now think of these 25 means as a sample. And then we compute the standard deviation of these 25 data points or of these 25 means. There will be just one mean error, and that mean error is the standard deviation of these 25 means. Okay? Good. So the population mean here is 30, and these are the 25 different data. Let's think of these means as the 25 different sample data points. These are the means. These are the means of these small 25 samples. Now the difference of the sample mean from the population mean, which is the variance, right? I determined the variance or the difference, and I squared it like we do in case of our when we compute the variance. So 10 minus 30 whole square, 15 minus 30 whole square, 20 minus 30 whole square, and all these. The sum of the difference of the sample means from the population mean is 2500. So when I add all these numbers, I find out this: sample mean, population mean minus sample mean whole square, population mean minus sample mean whole square, population mean minus sample mean whole square, right? So, and then I add that sum is 2500. Okay. Standard deviation of the sample mean is 2500 divided by 25, or 25 minus 1, however we say is the, as I mentioned that it can be, we can say n or n minus 1, whatever it is. So 25 here is the n, are the 25 data points, are the 25 means. This is the sum of the difference of the sample mean from the population mean. Square of the sum of the difference of the sample mean and the population mean, divided by the sample size, which is 25, the 25 data points of the means that we collected, and then under root of that, so the standard deviation is 10. 10 is the standard error of the mean. Is it clear now? Is the concept clear now? Thank you. Now, standard error of the mean, we also have okay, you are most welcome, anytime. So, the standard error of the mean can also be found by using this equation, which is standard error. Now, there was, next time I will surely scan those pages, and it was difficult for me to write everything, but let's discuss it now, and then I'll scan those pages, I'll scan those calculations and bring it for you so that it's more clear to you. Standard error of the mean is equal to standard deviation of the population divided by the sample, divided by the size of the sample. Now it's clicked here. So now we were talking about the standard deviation of the means of the samples, but over here we are saying the standard deviation of the population. Well, that is proved by the equation. That is an empirical equation that says that the standard error of the mean is equal to the standard deviation of the population divided by the data points that we have in our population, or the data points that we have in our sample. Right? So in our example, the standard deviation of the population, if I compute the standard deviation of this population here, is equal to 14.1. You can do the math. You can do this in Excel, and you'll see that the standard deviation of the population that we have here, which is 10, 20, 30, 40, and 50, is 14.1. 14.1 divided by under root 2, and 2 is the size of our sample the samples that we drew out of that population is equal to 10. And you see here, this 10 is equal to this standard error 10 here. So a standard error of the mean can be computed using this equation, which is standard error of the population divided by the size of the sample, under root of the size of the sample. Okay. Now, we have been talking about the population and the sample and all that. As I said, that when we say population, actually, it's again, population in our finite terms could be a sample as well. What do you mean by 3 values? Like the sample size 3? That is what you mean? Well, if it's 3, it could be 3, then this number will be different, because then the mean will be different, the standard deviation will be different. So this number will be different. So it could be 2, it could be 3, it could be 4, whatever you want to draw out of it. Okay. So the formula of the standard error can be rearranged to find out the sample size. These are all the derived formula. These are all the derived equations, which is the sample size n is the sample size here, is equal to the standard deviation divided by standard error whole square. Okay. So now you understand the concept of standard error. How do you find out the standard error? And then computing the standard deviation of the population is not difficult. Okay. However, it so happens then in the practical world, in everyday world, we usually do not know the standard deviation of the population. I can call a population as a large sample, right? It's not. When I'm saying population is an abstract concept. Although we said that over here our population was the ages of the 5 people in our group, but I can say that it's a sample drew out of even a larger population, which is not even present there. Understand? Is it clear to you that when we say population, then population itself could be a sample? Okay. So, in the practical world, we do not know the standard deviation of the population or a very large sample. So, we may have to estimate from the sample. So, I can call the group of 5 people whose age I know as a sample as well. So, I will compute the standard deviation of that sample, divide it by standard error, square it to find out the sample size that I need to be more confident about my claims or the conclusions that I draw out of that data set or that sample. Now here, as I mentioned, that we have different confidence levels. We say we are 90% sure. We say we are 95% sure about our claims. We say we are 99% sure. We never say we are 100% sure. So when we claim that we are 90% sure about, and then one more thing, look at this equation. The higher the standard error, right? The higher, like when we say that the standard error is low, the standard error is low, we need more sample size. So when we have otherwise when we have more sample size, the standard error will be low. When we have higher samples, when we have a higher sample size, the standard error will be low, or when we have a smaller sample size, the standard error will be high. So the higher the standard error, or we can say that to reduce the standard error, we always need to have a higher sample size. So if our claim is that we are 90% sure about our data, we are 90% confident about our claim, then the standard error is equal to